Hello friends, today we will look at LeetCode problem number 137 and it's part 2 of single number or version 2. So here the question is that you are given an array of integers and every number occurs 3 times, but one of the numbers occurs just one time. So you have to find that single number. And it's version 2 because there is a version 1 of single number where the problem is quite simple. Every number occurs twice and one of the number occurs once. So there if you do XOR of all the elements, you get that single number. But here the problem is slightly more tough because every number occurs 3 times and one of the number occurs 1 times. So if you do XOR of all the elements, so let's say A occurs 3 times and B occurs 3 times and C occurs 1 times. So you know that A XOR A will always be 0 and 0 XOR anything will be that, because in XOR if both the bits are 1 then it's 0, if both the bits are 0 then also it's 0. So if you take A XOR A, these first two will make it 0 and 0 XOR A is A. So 3 times is same as single time. So it does not help here. So we will look at a few solutions. So first will be more intuitive and then we will look at a more elegant solution where we will use XOR. So first we will do it without using XOR. So let's say in our array we have numbers. So we are not bothered about what actually it's in the decimal, because every decimal is internally represented in binary. So it would be more easy to look in binary in order to visualize. So let's say this is the first number, the second number is also this, and there is a number 1 1 0 1 and again 1 0 1 0. So you see this 1 0 1 0 occurs 3 times, here, here and here, and this number occurs just one time. So we should return the value of this. So the idea is very simple and you can even, anybody can solve it. So let's say we are dealing with integers and the number of bits used by integers is 32. So we can have an array of size 32. And this 32 denotes the 32 bits to represent an integer. So all of the integers in this list will have 32 bits. Some of the bits will be set, some of the bits will not be set. So here we iterate for all the numbers of this array. And what we do, we first we look for all the first bits of all the numbers. So we can have a loop here for I equal to 0 to 32. So this is not order of n, this outer loop. This is just constant 32, denoting 32 bits. So first we will look at rightmost bit or least significant bit. So I is 0. So we don't need to shift anything. So we will do AND with 1. So 1 is, if you remember, 0 0, everything is 0. The least significant bit is 1. So if we do AND with any number, then everything will become 0, except if this bit is set, it will be 1, otherwise 0. So if this is set, then we add AR0 plus plus or ARI in this case. So in this way, we will count how many numbers have this first bit set. And here, instead of just adding 1 to it, we can also store modulo of this, modulo 3. Because whenever it occurs 3 times, we have to reset that. Or you can do everything in the end also. So let's say now you have the count of all the bits. So here it will be 1, here it will be 3. You see this bit occurs 3 times, this occurs 1 time, and this number is other way here. I am storing in I, so 0. So you can think of it as 1. But for visualization, let's keep it here only, and then 1, and then 4. So now if you take modulo 3, this will be 1, this will be 0, this will be 1, this will be 0. This will be, sorry, 1. 4 modulo 3 is 1. So we get 1, 1, 0, 1, which is the required result. So first let's write the code for this in LeetCode. Then we will look at the other solution where we will use XOR. So we initialize it with 0. So we look for all the bits. So initially when I is 0, we are looking at the rightmost bit, and then we will iterate for all the numbers. So num right shift 0 is nothing but the number itself. But when we want to look at this second digit from the right, we have to shift everything to the right, and then again do XOR with 1. Or we could have left shifted 1 also, then again right shift. So in fact we don't need to do that. We need to do this just one operation. Now we have the count of all the bits. So result equal to result or bits I. So whatever bits are left in this bits, the count, we are adding it to result. We are building result out of that. So this bits, if you look at this array, it's binary representation. We are converting that binary to decimal, and we will return that. And let's run it. So there is some error here. Okay, it's n, not num. So this solution works. So let's go ahead and submit it. And it's not that good. the runtime. Let's try to submit again. So the same solution, if you try a few times, timing will vary. And here you can see it's better than 70%. So this is quite good, not that bad. So now we will look at the other solution, which is using XOR. So here the idea is that we will keep two variables, ones and twos. So ones will hold. So we will iterate through all the numbers of this array, and after each iteration, ones will hold the bits which have occurred once. For example, when we just visit the first number, then these bits are 2 and 4, these have occurred once, and none of them have occurred twice because we have not even looked at two numbers. So at the end of one iteration, this should keep 1010, and this should keep 0000. So this is after first number. Then we move here. Then none of the bits have occurred once because this has occurred 0 times, this has occurred 2 times, 0 times, 2 times. So ones should hold 0 and twos should hold 1010, because this bit has occurred 0 times, this bit has occurred 2 times, and this twos keep track of that. So whatever bits have occurred 2 times, these will be set to 1 here. Then in the third iteration, we have to see which has occurred once. This has occurred once. This has occurred twice, so this would be 0. This has occurred once, and this has occurred 3 times, so it should also be 0. So 3 times is equivalent to 0 for us. We only need to find the number which occurs once. So we have to reset everything if it occurs 3 times. And then what should be the value of twos? So this bit has occurred twice. This has occurred once, so it should be 0. Then third bit has occurred once, so this would be 0. This has occurred thrice, so this should also be 0. And finally, one should hold this 1, and this has occurred 3 times, so it should be 0. This has occurred once, so it should be 1, and this has occurred 4, so it should be 1. So this once will hold the bits of this number once will be true for the bits which has occurred once, 4 times, 7 times, and so on. And this 2 should be set when it's 2 times, 5 times, 8 times, and so on. And if we have anything 3, this is same as 0. So in the end, when we have iterated through all the elements, this once will be the value that we are interested in. So how we can do that? So let's run through an example. So we will initialize this ones and twos with 0. So initially they are 0, 0. So we have remaining 28 bits also, but since here for our example it's 4, it would be easier to visualize with just 4 digits. And twos are also zeros because we have not started looking into the array at the moment. Now what we will do, we have to iterate for all numbers. So let's say these are stored in nums array. So we will have, so after each iteration, this invariant is true, that this ones hold the bits of ones are set for the bits which have occurred 1 times, 4 times, 7 times, or we will think of it as just 1 time also. These are all equivalent to 1. And this has occurred twice. So when we encounter a new number, what we would like to do, so whatever is stored in 2, let's say third and fourth bit are set to 1 in this, second and third. So this means that these bits have occurred twice. And now I have given, I got another number, which is, let's say, B3, B2, B1, B0. I want to keep track of what digits have occurred, what bits have occurred twice. So what we will do, so some bits should have occurred once. So in once, some different bits should be set. So whatever bits have occurred once, and those bits are, if present here, then the exact same bits will occur twice. Because let's say bits B0 and B3 has occurred once. And these were 0 in once. So B0 and B3 had occurred once, but if B0 is also set in this new number n, then its count will be 2 because this had occurred once and it's also set here. So it should be included in the value of 2. So what we will do, we will take 2 or once and n. N is the new number. So whatever bits were already set in 2, they will remain there and some new bits will be added with the help of ones. But after this line, you will see that some bits in 2 was 1 already, but it has been added here because of this. So this bit will still remain 1, but it has occurred in fact thrice because this bit was present in this new number. So in 2 also it's still 1. It should have been 0. So now 2 contains 2 and 3. The bits which have occurred twice and thrice, both. So we will get rid of this soon. First, let's see how ones will be updated. So some bits have occurred once and one is keeping track of that. So if we do XOR with new number, so this new number has some bits set, so those will become unset here if it was already present in 1 because those bits had occurred once and these are also present in new number. So now it has occurred twice. So we don't need to get rid of that, and this XOR will exactly do that. But in once, if some bits has occurred twice, let's say this B3 has occurred twice, so it was 0 in this 1. But this B3 was present in the new number n. So this is in ones and this is in n. We are looking at B3. So this can be 0 due to 2 reasons in ones. Either this bit has occurred 0 times or this bit has occurred 2 times. So if this bit has occurred 0 times, then correctly now it holds 1. That is 1 times. But if this bit has occurred 2 times and it was, so that's why it was 0 in ones, but now this bit is present in n, so this will become 1. So now this once holds all the bits which has occurred once or thrice. So this 2 now contains all the bits which has occurred twice and thrice, and this once contains all the bits which has occurred once and thrice. So what is the common among these two? The common is the bits which have occurred thrice. So we can have another number thrice, and this will be 2 and once. So the common of these will be the bits which have occurred thrice. And now we get rid of this thrice from both 2 and 1. So what we will do, 2 equal to 2 and not of thrice. So the bits which have not occurred thrice, we do AND with that, so that thrice bits will get chopped off. Similarly for ones, equal to ones and not of thrice. And finally we will return that once. So let's write the code for this. So let's run it. So this works. So let's go ahead and submit it. So again, this works, and you see that here time is better than our earlier solution. Most likely because this here we are doing modulo a number of times, and these operations are generally not cheap. Here we are not doing any of such operations. We are just playing with AND or XOR, not these kind of bitwise operations. So it's giving very good result here. So I hope you understood both of these solutions, and we will see you in some other question of LeetCode.